It's a big one.
We'll put it up as soon as it goes.
All right.
Stand by on the Mac. He's going to start uploading it.
We're in the business of producing enormous high-resolution images, so this will take probably a couple of minutes to load.
You're going to start. We'll bring it up as soon as it comes. You want to just do a little.
Okay. All right. Well, I'm going to tell you today about our work in the Dominican Republic, which was inspired first by our work in Cambridge. I'm going to introduce this subject really by focusing on invasive species. The first invasive species in the Americas, which not surprisingly invaded at the place where the Americas began, which is the island of Hispaniola. I work in the Dominican Republic, first and foremost because my spouse is Dominican. She's from Santo Domingo. And the Dominican Republic and the adjacent country of Haiti have also been subject to study by my museum for about 150 years. So we have a lot to bring to our studies of the Dominican Republic there in site and also in Cambridge. And we've started an exchange program of bringing students and scientists between the two places. So I'm going to start today with a mighty mystery, a 500-year-old mystery, a mystery of an invasive ant species which appeared out of nowhere and caused the movement of the city, the nascent city of Santo Domingo, from one side of the Rio Azama to the other side of the Rio Azama. This was described by Fray Bartolomé de las Casas in his wonderful Historia de las Indias, which was based in partly on the logs of Christopher Columbus. So if I can paraphrase here, this here's reporting on the plague of ants in the monastery of Concepción de la Vega. This was the infinity of ants and the damage that they did against the trees that they destroyed. They were thrown against the oranges and the pomegranates, and they were generally, well, there really is no exact English translation of the word rabiosa, but think the most pestiferous possible. And the people that they bit and caused major pain, and you couldn't sleep unless you put the feet of your beds in buckets of water. They started to feed from the roots of the trees, and this way they destroyed most of the gardens in the city of Santo Domingo. And the cause of the origin of this ant is believed by some and said by others that they were brought and traveled with the platanos. Well, it turns out that that was a clue. This particular mystery is familiar to every Dominican. Everyone grows up knowing about the extraordinary invasive species of ant which caused the movement of the city of Santo Domingo. Well, I spent a sabbatical year there a couple of years ago, and in order to solve the mystery, I imported the best ant taxonomists I could think of, E.O. Wilson. My spouse, Irina, is also an agronomist, did a translation of the original Spanish, the Old Spanish, and she realized that there were a couple of clues there which had been overlooked, which, when supplied to Ed, caused the resolution of the mystery. So the clues were that the plantains, basically, what we realize is that plantains, whenever they're brought from Africa to a new place, like to the New World, they're invariably accompanied by scale insects, sucking insects, which themselves feed on plantains and are also very able to jump onto other kinds of plants, agricultural plants like oranges and pomegranates. Well, it turns out that wherever scales and plantains are found together, which they invariably are, ants discover them. Ants husband, they basically take care of the scales insects, they protect them from their natural enemies, and in return they get sweet substances, sugars, which the scales produce. So what Ed realized is that this mysterious ant wasn't some unknown invader, it was a native fire ant which had discovered this new resource and exploded in abundance when it was able to feed on the new substance produced by the scales, and in return the scale insects moved from one plant to another, causing them not to be defoliated, which really this doesn't say. What it says is it causes the plants to turn black. And what scales also do, besides being accompanied by ants, is they transmit a Phytophthora fungus, which causes plants to turn black. So we put all these clues together, and of course, Ed, in his wisdom, realized it was a native Phaidole, or a native Solenopsis species, a native fire ant, and of course, received a fair bit of attention in the national press over the next couple of weeks. Now, this was a couple of years ago. Just a few weeks ago, the story of this broke in the journal Nature, and the New York Times picked it up as well. And I bring up this example because this was a mystery which lasted for 500 years, but it needn't continue that way. It needn't, because we're able to now document what's native to a place, and so we can figure out what's new when it arrives. We're focusing on the Dominican Republic because it was singled out in the island of Hispaniola as one of 25 biodiversity hotspots worldwide, which together collectively represent almost 44% of all the plants and vertebrates in a very tiny fraction of the area. So if we focus on understanding and saving these, we've gone a fair way towards understanding biodiversity on the planet. So this is the website focused on the Caribbean of Conservation International that gives you some of the information about the various groups of animals and plants that occur there. Now, you might at first glance have the impression that, in fact, we know a fair bit about the biodiversity of the Caribbean because we have these wonderful field guides to birds and to some other vertebrate groups. But in fact, those are just a small fraction of the diversity that occurs there. Most of the diversity are invertebrates, for which there are no field guides. Moreover, there's not even any literature which would allow you to decide whether an ant, which you newly collected in the Dominican Republic, was a new species, an old species, or an invasive species coming from someplace else. The literature just doesn't exist. Most species of invertebrates, which are of much greater economic and medical importance than vertebrates, are identifiable only by looking at museum specimens which have been previously verified to belong to a particular species. Now, in a museum, there's only two kinds of specimens. There are type specimens, and there's everything else. Type specimens bear the name of a species by definition. All other species identifications are opinion, including that of Homo sapiens. There's one skull which bears the name Homo sapiens, placed there by Linnaeus. The rest of us belong to the species by more or less informed opinion. We can always be proved wrong. Most species on Earth have no field guides or literature for identification. Most species can only be identified by study of types. And these types, for reasons of history, which are well known, are concentrated in a few large museums in the north, including my own. So we've started an effort to repatriate the information from these type specimens back to the countries of origin. We've started to document using digital technology the insect types in particular in my department, and we're working our way across the other departments. So this is our website. This is the staff imaging with scanning cameras the type specimens. And this is an example of a beetle head, which you can see kind of out of focus here. And in fact, this particular head is only in focus a little bit at a time, depending on where you're moving the microscope through the focal layers. It's too small, really, to see fully in focus at any one time. What the software does that we've been applying to this problem, we take photographs at different focal layers, up to 20 or 25, scanning through the image, and then the software stitches those all together into a single, fully in focus, almost three-dimensional image. Unlike an image unlike any ever seen before of this particular species. These are particularly large images, so they take a minute to load. So let's just wait through it. So we've been working across the various Caribbean islands, doing all of the types of these particular insects in the Caribbean, as well as all of the other insect types that we have in the Museum of Comparative Zoology. We're also doing the Caribbean types for other departments as well, as you can see. And we have quite a good collection because of the history of my museum in the Caribbean. In fact, for some groups like reptiles and amphibians, we have about 90% of the types of all the species that occur there. We have a long history, 150 years of exploration, culminating in the middle of the century by my predecessor, Phil Darlington, who spent quite a lot of time in the Dominican Republic in particular, collecting many new species of insects, but storing all of the material and publishing his observations in journals and storing it in places which are inaccessible to Dominicans and others who would otherwise have use for that information. This is one of the specimens that he collected in 1938 in a place that I visited this last summer. This is a high-resolution image which is now on the web and available to Dominican students. As another layer of an investigation, I've started to bring my class, my Harvard University class in systematic entomology, down to the Dominican Republic, first over spring break to collect insects along with Dominican counterparts. We work at the Punta Cana laboratory in the eastern part of the country, and the Harvard students, alongside Dominican counterparts, collect extraordinary beasts that occur there. And the diversity is really quite stunning. Including extraordinary butterflies. Remember this image. I'm going to come back to it in a minute. It's exhausting work, obviously. The students learn to mount insects from Dominican scientists and preparators, as well as Dominican students, drawn from the oldest university in the Western Hemisphere, the Universidad Autónoma de Santo Domingo, founded 100 years earlier than that upstart Harvard in 1538. The students learned the various ways of collecting insects, including fogging the rainforest canopy, which we do. All the insect rain collects in this parachute. We sort the material, load it into a database. Here's a Dominican preparator teaching our students how to mount insects. And everything we put on the World Wide Web by the end of the semester. So this was the beginning of this database of this inventory, this catalog of insects and plants for the island. First created through bringing Harvard-developed technology through a field course, and now established there as a Dominican-run enterprise. So the website is rather comprehensive. We have various dimensions, including the database, which is the heart of it. We also have an aspect, this is all available in Spanish as well as English, an aspect that's for K through 12. Which we're now, as we'll see in a minute, using there on site. So a young student need not have any entomology or even know really what the difference is between an insect or a spider, but if they have a small animal in their hands, they can find the shape. And if they click on the shape here, like if it's a beetle, let's say, they'll get this web page in Spanish if they're in the DR with photographs of local species and information about their ecology, biology, and how to prepare them for a museum. This is the heart of the system that we've developed. This is the database, which you can search on. Has orders and families, et cetera. So you can search on a family like the Lycidae. It's a particular kind of beetle. You come up with the images, this of the dorsal aspect, and then of the head, the ventral, underside, side views, and then the label, including a barcode. Everything is barcoded for easy retrieval. So this was started about 3 years ago, and 2 years ago I decided to spend a sabbatical year on site at the National Botanical Garden, where I worked with the Dominican students. I brought my, thanks to the National Science Foundation, my assistants from the museum down to train the students, and we started documenting their national collections, which lends value to the collections. It provides a searchable index to those national collections and provides sort of new attention to them in the eyes of administrators and the public as well in the Dominican Republic. These are some of the images now taken by the Dominican students and not by our staff. That's a 1 millimeter scale bar. That's a tiny beetle. Here are all of its near relatives that occur in the same country. There's about 100 species of the same genus. Here's another tiger beetle from the Dominican Republic. Again, multiple views. These images taken by the Dominican students with equipment that was donated for the purpose. Now, it occurred to me that one could have this wonderful online website, and I could describe it to you, for an hour, let's say, about how useful it is. But then I realized that, we can take those images and do other things with them, like build field guides that you could then customize for hotels or for schools or for particular ecological regions and distribute them freely. So we've started to build this. Last time I taught the course, the students took the images right from the field guide and then wrote English, and then we're now producing Spanish text. We're also producing posters. So last year, I had the idea to buy a poster printer, and I brought some of these posters with me today. I'll leave these with you. These are distributed to the Dominican elementary schools and the orphanages there. It has our website for further information. They're in Spanish. They have the participants and so the URL so that folks can go on farther. These are dragonflies. Here's one to butterflies. These are going around to about 5,000 schools through the Secretary of Education down there. And I've found that my friends in architecture and art like the dragonflies the best, I think, for their geometry. Now, I told you I was going to return to this. Here's some weevils. I was going to return to this butterfly. Maybe the snake won't mind too much, or maybe it'll get hungry. I'm going to come back to this species of butterfly, which we found last spring in the Dominican Republic. It turns out it was new. So let me refer to that in a second. So not only can one document the native fauna, put it on the web, provide the materials for education. I mean, I can describe the website to the students in schools down there. Some of the schools do have computers, but they all have walls, and so they all have ways of displaying this kind of information. These happen to be tiny little beetles. These are half-millimeter scale bars, and these are insects which cause about $7 to $8 billion worth of damage in the United States alone every year, about $100 million per country in the Caribbean every year. They do this damage by vectoring pathogenic fungi, which infect trees and destroy crops. And they're almost impossible to identify. Shipments are held up in quarantine at ports of entry because there's no expertise able to identify these insects to know whether this is a new one, this is an old one, this is something that's destructive or not. So we've started to also document particular pest groups. And we're using the information. We can use the images to produce posters. We can use the localities to produce maps of the species. And we can distribute information like these advisories. We collected this butterfly last spring. One of my Dominican counterparts recognized, hey, that's new. I've never seen that in the DR. We emailed quickly an image around, and we discovered that this was not only new for the Dominican Republic, it's new for the Western Hemisphere. This is an important citrus pest in Southeast Asia, where it causes many hundreds of millions of dollars worth of damage to orchards and nurseries throughout Malaysia, southern China, adjacent India, and it's spreading throughout the Pacific Islands. Well, it's now going to spread across the Americas. Based on our observations of collecting just 2 specimens first, the USDA mounted a task force along with their Dominican counterparts, and they documented that, in fact, this species is now established in the middle of the country, where the vast orange plantations occur, and in fact, it's spreading like wildfire. It'll be in California within 10 years, no doubt. This is an extremely fragile flyer, and it'll hit Florida probably in the next 3 or 4 years. It should range all the way down to Argentina if we can predict based on its old world distribution. So it's an interesting case that certainly it's important to document diversity because it's disappearing. It's even more important to document it because it's invading. We published the first record of this in a journal that just came out. And our newest venture, which bridges to the next speaker, my close colleague Craig Venter, is to provide DNA barcodes of every species on the island. This is a place where you could potentially document everything. There's probably 15,000 species of insects, really a drop in the bucket. And most of them are related to each other because it's a very distant island, an oceanic island distant from the mainland. So one could document everything that naturally occurs there and know whether something is new or not, based just on DNA sequences. So this system together strengthens it basically forms this kind of a pyramid of reinforcement where national parks and reserves supply specimens to national collections, which in return supply information back to the national parks. Those collections and their digitization provide maps and field guides for use in education, conservation, and ecotourism, which then use the information to visit the national parks. So we're envisioning a scheme here where all the players win. This last week, I gave a talk on this in the Dominican Republic, and I was delighted to see a group of students from a local orphanage which had discovered our website and started using it to teach the students how to collect insects and how to do science, basically, how to make observations, record their observations, make collections, and start this educational process. So the students came to my talk, drove about 6 hours. They printed out all the web pages, plasticized them, and they use them as a teaching guide in their courses. So really a very inspirational moment for me. This, we hope, will eventually result in a fully digital map of this island as a model for other larger continents and larger islands, where every species is known, where anyone with a computer or access to a computer lab or a cafe can gain online information quickly, and importantly quickly, to the biology, the ecology, and the name of every species that occurs there. Thank you.
Oh, thank you.
Just wait. I've got one question for you. Okay. So, is this live? Yeah. Are you making available the technologies and the ideas for other groups so that they could repeat basically the work you've done for other places?
Yes, part of our mission is to document everything on the same website. So in fact, we have manuals fully illustrated in both Spanish and English that you can download, together with suggested vendors, the price list of all the equipment, everything, all the specs, exactly how to do it, the protocols and everything. The whole idea, the model, it's interesting. Every semester I get a couple of emails from students in the Harvard Law School saying, you've got to copyright this. This is fantastic stuff. My reply is, no, please steal this site. The more the information is used, the better. That's our measure of success.
Thank you.